we're using, it's a mathematical model based on the principles of probability, statistics, and all that. Because probability and statistics, I'll show you, they use a lot of random variables, and this election, the polls are all random variables. There is not deterministic there. We'll talk more about it when I go into the figures. So based on that, we predicted that the end, you will see what we predicted. I'm not going to say right now. And then we go from there. Kendra, next. Can you go to the next one?
Yeah, just give it a second here. It's loading.
Yeah, this work is done by 3 people, me, and then there's Brian Sloboda, Department of Labor, and Vinny, who is the student. But he was a student at Cal State Fullerton. He did his mechanical here, and then he went to Chicago, and then right now he's doing his PhD. So the teamwork, as you can see in the team itself, it is interdisciplinary. I'm in engineering, Dr. Brian is in economics, and then Vinny Pramati is in electrical engineering. So that's what happens when you go to the higher level. There is in the engineering, mechanical, physics, chemistry, mathematics. I used to do a lot of consulting work as a professor here. Once a week we're allowed at Boeing. So the research team, when we worked on space shuttle, was all consisting of people from various disciplines. Yeah, go next one. Can we go to the next one?
Yes, I'm waiting for the slide to move forward. 1 second.
Not going.
Okay.
Okay, this is all a general philosophy of reliability analysis. In this, what we are saying here is there are 2 that we have. I'm not going to read this. One is called deterministic analysis, where all the variables are fixed. The other one is called probabilistic analysis, where the outcome is uncertain. It's a random variable. So, and that one has a lot of this, something like that, what it here. Normal distribution, viable, and all that. One of the most common use, as the name says, is normal distribution. And every distribution has density function and then it's associated with it. So based on we used our main random variable is the poles. Earlier, when we were doing analysis, we were asking at that time, the Bush was there. Iraq isn't going to have any effect or not because the war in Iraq. So what we did, I said, everything comes into the poles. So even now, we are using a single variable, using the probability distributions and the reliability analysis and coming out with the outcome. Yeah, go next, Kendra. What I'm saying is what it says to the extent that poles have been used and the model has been. So as it says now, again, this one, the United States, we know, as typically a 2-party system, especially the people from India and all that are attending. Unlike India, where there are multiple parties, here it is typically two parties, Republican and Democrat. So it becomes easier to do the mathematical analysis compared if you have 15 parties. So, and then of course you do have, maybe I shouldn't say 2 main, then you have got libertarian and other parties and all. Okay, move on. Oh, one more thing here I'm saying here. The engineering model development will concentrate in the actual general presidential election, not in primaries. But you know that, to come to this level, whether you have a Democratic candidate or a Republican candidate, they'll be elected only through primaries. And these are bitterly for first time earlier when Trump got the nomination, there were like 11 people. Then the whole thing came to 1, and then whatever happened. Similarly, now we had other people now, Republican Party, Democratic Party also. We don't have, it didn't go that way because President Biden decided to opt out, and so we have Kamala Harris. But in the beginning, generally even Democratic and Republican also. The second paragraph says not in primaries, but actually in a way primaries are embedded because the candidates are coming based on the primaries. Okay, move on. Next one. Yeah. So the thing is, as I said just now, we're going to use mainly the normal distribution because we have, if we say normal distribution, we cannot just say based on the data that we have. When you go and fit it, there are tests like chi-square test. There's another one called, I don't want to bore this, it's not an engineering class, Kolmogorov-Smirnov test, and we mainly use chi-square test. And we found that the pole data is all normal distribution. So if you look at this one in the bottom, this is the density function. And what is it that we do with it? When you take the poles and then you have take the mean value, standard deviation, as much as you can. Then the question is, there's a threshold point, when somebody has to win. So you use that threshold point and then calculate the probability. For example, normal distribution goes from minus infinity to infinity, okay? And then for any limit that you are talking about, you can put it and then calculate the probability. That's what we did. If you go and look at the tables later, which I will say, that two things that are shown. One is called mu, the other is called sigma. The main parameters, actually the parameters of normal distribution. Once we get that, we calculate the probability. It is as simple as that. And that is the model which we use rarely. We were right several times. It doesn't matter which model you use. The poles are very important. If the data that we got is wrong, the outcome will be definitely wrong. It doesn't matter what sophisticated model you use. So the bottom is affected is sensitive function. The parameter goes minus infinity, but the action depend upon the data that we use that and then get the so the way to do it is you go from infinity to calculate this area, separate this, and then you get the required area. That's very important when we do the calculate values and various poles affected by various agents in state United States. Yeah. Next one. Kendra? What happened? Yeah. So as I said, we use mainly the chi-square test. And here, what is this x minus mu by sigma? It's because the density function that I showed, you don't have any closed form solution to it. So one goes with a standard variable, then you reduce it to a standard normal distribution, for which, when you calculate the probabilities, there are tables, and one can calculate the necessary probabilities. Okay, Kendra, next. Okay, this information declaring the winner. Okay, as you all know, in the states, there are two things that are very important. But the important thing, the electoral vote necessary. We have last time when I think when was Trump, Hillary has more popularity vote, but at that time Trump got the more electoral college. So as we are saying here, this implementation, in addition to declaring the winner, will also have electoral vote. Most of the states have winner take it all, except I think 2 or 3. So based on that proposal, we did the modeling as I showed you just now, the mathematical basis, and then we calculate the votes, and then we're predicting it is based strictly on probabilistic analysis. And there is a lot of, we use another thing called uncertainty analysis. Okay. And later on, when we go into the results, we're going to use a factor called uncertainty factor. And I'll show you because in all these polls, there are 5 states we did not have the polls. So that one, naturally, you have to assign based on the historical data. And also you have other going into picture. We had to use the, typically that used the uncertainty factor.
Dr. Putra's connection. Dr. Putra, are you there? Dr. Putra, I believe you're on mute. Dr. Putra? We're not able to hear you.
How about now? Can you hear me?
I can hear you well.
Okay, fine.
Okay. Okay.
Sorry.
Thank
I didn't do anything. It happened suddenly.
you.
Okay, let's go to the next one.
Okay.
Now, can we make it a little bit big so people can see?
One second. Let's see.
I don't know. I can see. I don't know how many people can.
Is this size okay?
Yeah, this is fine. I think you can see this, right, Kendra? You're okay?
Yeah. Yeah.
Yeah, I think this is fine. So here you can see we have different poles. So first I gave you the mathematical basis. Now this is all. We wrote a program which does all these things. We have, as I said, we have 3 people working. One of them is a PhD student. He was our student here. So he developed a program, put all this in Excel. And then we're telling you that, for example, look at first one, Republican and then Democrat. And as you know, whichever gets maximum, highest one will get the electoral college. That will come in the next table. Okay, move on.
Okay.
Kendra, go ahead. Yeah, so polling data again, these are all different sources. And make it bigger, please. This one, even I can read it. Kendra, a little bit big.
Next slide.
Can we make it a little bit?
Oh, sure. One second.
Yeah, okay, now we can see. So we have that all the Jones, Zigley, active. So all these things we did, and then these results. Move on to the next one. Next one. Table 2. Move to the table. Keep moving. Not going. Yeah, right. This is still. I think we'll move on. These are all the polling data. All that. Okay. Now here, as I said, for state we didn't have the data. Hawaii, Idaho, Kansas, and then Kentucky. So we had to fill in the place based on the previous data that we have, which is realistic, but then we adjusted it based on the uncertainty factor. Okay, next, move on. Kendra, next. Yeah, this for now. And then for Trump, based on that, for the curve, we can calculate the based on the threshold value of the winner. 45%, I think, or some number. We have the data. We use that and then calculate the necessary probabilities. Okay, move on. Next one. Next one. This is all for each state. Kendra, please. Okay. This is again for other states we have. And now this one has, this is the electoral votes. Okay. So winning probability you have, and for each one of them we have Alabama and then Florida, the electoral votes that based on the polls they are allocated. Okay. Now next one. More. Okay. Now this one is an important table because now here also we're doing the probability. Go down now. Now this is the one that everybody likes to. So we got, if you look at the first one, is the one that based on the polling data. But then here, this is what I was saying. We have to use the age and race. Over and above it, as I told you, the 5 states, we didn't have the actual polling. So we had to fill in based on the historical data. So definitely there is uncertainty factor. If you do that, the most important for you is this one. 267 for Harris and Trump is 271. Very close. As we predict that popularity vote, of course, Harris, again here is Trump is more. But I personally feel that it's possible that, Harris may get popularity. We this we feel that Trump will go. You have next one. Yeah. See, here people don't, they are not too much interested in probabilities and all that. But based on the probability model, they're saying here, Trump should win the 2024 presidential. Then also saying that he will win, even though it's any of the swings, Trump is winning. Anything can happen. But our model says that this is what we're going to go out. Whether we're right or wrong, November 5th will tell. And this is based on sound mathematical principles. Again, other people may be predicting, somebody else I think is predicting based on it. That's more qualitative models. Like, for example, they have like 10 or 12 factors they have. For example, one of the questions there was, is the candidate has a lot of charisma? Like that, and then you add them up and they are declaring somebody. And based on our thing, we are saying that, Trump will win. And I told you how we came up with this particular conclusion. And I try to make as less mathematical as possible. I do teach these basic courses, probability, and I don't want to make it a course on probability and statistics. People will run away. So this is what our conclusion is. And now, Kendra, anybody wants to, I don't know, she can throw the thing for discussion. They can ask anything they want and comment anything. It's a controversial thing, and especially now, it is so close that we don't know what's going to happen. But I told you what is going to happen based on my model. But I think at this point, I'm going to maybe declare Kendra to let the people ask any questions to comment and all that. So I'm going to, I think, end this at this point, my actual presentation per se. But I'm here, I'm not going anywhere.
Thank you, Dr. Puccio. We'd like to open up for any questions.
Yeah,
If,
please. Unless nobody wants to ask anything. I don't know. We'll see. There are no questions? Nobody is interested in the election or what?
I have a question, one question, Dr. Puccio.
Yeah, okay. Hi, Prathana.
Hi, Dr. Puccio. So thank you
Hi.
for your, findings and the effort to predict the presidential election for 2024. My one question is regarding the 7 battleground states, how do you see the uncertainty is going to change versus the total, the popular vote?
You want me to go to the results?
I mean, just for those 7
Oh,
battleground
you're asking me
states.
just fundamental question. No, the thing
Yeah.
is, for the 7 states also, we took the polls and the whole uncertainty and everything, you're right, there is more uncertainty there. But we lumped everything in total mathematical model rather than just those 7 states.
Okay. Yeah,
Okay.
that was my question, because
Yeah,
there are like
I
different
hope
pathways for both of them to win the presidency. So I was wondering, like, one way or another, how it will,
Right. So we did not, no,
double.
you're right, Dr. Gore. We didn't separate it. We put the whole thing, we wanted to make the model as simple as possible. So we, all the points you're saying is right. The most important one is the swing states, as you and I personally talked also, rather than the national poll. And that one, since we take the total model, the uncertainty comes into picture, and we used the factor of gear, which is the gender, ethnicity, age, and race, plus the fact that the 7 states don't have the results, that I think we feel that they should take consideration should take care of the kind of, well, it's a good question that you have. Question
Correct.
that you have.
That's
That's the
yeah, that was my question. Thank you.
Thank you.
Hi, Dr. Puccio. This is Murthy calling. Hi.
Yeah, Dr. Murthy, go ahead.
I have the whole model actually is, so of course the mathematical model is complicated, and of course I understand you are not presenting because this is just for the general population.
Right, I didn't want to make it
Right.
class.
I understand that one. So the mathematics cannot go wrong. So mean and standard distribution and calculation of mean and standard distribution. But
no, Murthy, hold on. Mathematical cannot go wrong. The polls are wrong. The output is wrong, right?
Exactly. So the whole thing really depends upon the polls. So what is the
exactly?
what is the confidence level you are assuming on the polls?
Based on that, it's about 97.4. That's what we calculate. 97.4.
That is the confidence.
When you do the distribution and do the confidence level, you calculate, and that's how we got it. It doesn't mean that we're still correct, but that's a high confidence level. That's what we think.
My second question is, before the election is over, is there any way this can be verified? For example, with the previous models you have, with the previous any previous predictions or anything, is there any way
Yes,
to
you are
verify that?
100% right. The same model, but we have tested it 4 times. This is
Ah.
the 5th time. And we were right 3 out of 4.
Hmm.
So the one we were wrong was when Trump got elected. So so that does show that the Bohr model has good mathematical basis. And the one when Trump got elected, the data was wrong in a sense. People were afraid to say that they voted for Trump, but they were voting for Trump, and we took it in the Hillary bin. So the question is right. It has been tested.
So that means is the polls. So the people who are afraid of publicly saying or admitting, so it can swing in any direction, even in this case.
Yeah, we can go wrong again. I hope I'm right, but I could go wrong.
No,
Yes.
not that. So we are not saying that the models are wrong. Models, of course, models are correct. Mathematics is always correct.
Correct.
But so the whole polls basically, when you poll the people because of various other social factors, probably they are not being truthful. Maybe.
Correct. And I'll tell you something else. Working like Murthy, we have 3 people. One of them is a PhD student. He's 32. He was telling, his thing is people less than 35, they don't even participate in the polls. So we were telling Brian and I, so you're the culprit. People, so it's not even going into the bin. So, and there may be so many people like that. And so the data gets corrupt in the sense, mathematical model may be right. So what? So, but still, we have to use with what we have.
Yes, I agree.
That's
But
and we're hoping that we'll be right. Unlike one more thing I had to tell you, and all these papers that I do, which is not civil engineering but other areas also, I have presented in the respective conferences. Like I went into political science conference when we lost the one where the results were wrong, but still mathematics were presented. They went into the conference. I was doing this because of my interdisciplinary work. Then by that time I was right. Times maybe. All the political scientists, for them, the bread and butter. They said we were all wrong. Don't we? Because they were all wrong at that time. So they were wrong. So, so point that you raised is an important one. If data is wrong, people have not, then naturally it can happen again. There could be wrong, but otherwise we do feel that this time we feel maybe the people are not that much afraid of Trump. I don't know about that. And we use the data that we have. We're hoping that, and to take care of all those things that you raised, we took care of through the uncertainty factor. Last time we did not use the uncertainty factor when we lost with the Trump-Hillary time. So we're hoping that this time will be correct.
That's good. That is a nice piece of work. You must have spent a lot of time. Yes.
Last time also we published in a good journal, political science journal, not civil engineering journal.
Yes.
Thank you.
That is good.
Thank you very much.
Yeah, thank you.
So there's a question in the chat. Is there a reason to think that those who are not answering polls are still voting? And what is the impact of early voting looking like?
Speak loud? Get somebody sent didn't want to come up, but send you the chat something.
Oh, there's a question in the chat
Who
for
has
you.
the question? Yeah, tell me the question.
Can you hear me?
I want to identify them. It's there, Ramakrishna Reddy to everybody. Okay. What is the question?
Oh, can you hear me?
Hello? I didn't
Yes,
get the
we
question.
can hear you.
I
Okay,
can hear
I'll
you, but
read
I
it
can't
from
hear the
the-
question that you
I'll
were
read
saying.
it from the chat.
Oh, it's my daughter,
Hi, Daddy.
Nilo.
Yes, hi, Daddy.
Okay. Okay,
Okay.
ask the question.
Is there a reason to think that those who are not answering the polls are still voting?
Yes.
Okay, they're just not answering.
They're just not, as I was telling Nilu, when we had the meeting, the guy is Vineet 32, they're not answering, but they will definitely go and vote. But they just don't have time to answer all these stupid polls.
are you looking at the impact of early voting? Or is that too?
It's a very good question. We did not use the impact factor directly of early voting. That's a good point. But the other uncertainties, we took care of it through the uncertainty factor called GEAR.
Okay.
We should have maybe taken care of that. But are you saying that the early voting would? Yeah, you're right. Early voting could swing the vote one way or the other. But that's a very good point. We did not do it last time. We didn't do it this time.
Well,
The only one we did this time, Nilu, is we included the uncertainty factor.
oh, no, that part is good. The issue is not that you could have done anything with it, but in the past, early voting favored Democrats, whereas in these last few days, it looks like early voting is favoring different
Favoring who?
one part early voting this last week. It's looking like it's favoring one party in one battleground state and one party in another. So it's not really changing anything. And it's so soon. I mean, it's only been like a few days. So there's nothing you really
But the
could have
thing
done to
is,
incorporate that into
so you're telling me that the early voting is favoring one part or the other when you look at the swing states, what do you think?
I think it's showing that it's favoring Trump in Pennsylvania, but Harris in some other battleground state, maybe Michigan, but it's only been a few days, so it's hard to tell. And also the other.
Yeah, but one thing, Nilu, see, the model has been developed by now. Okay, let us say the only way we could take care of the early voting is, again, it has to be lumped into the uncertainty factor. There's nothing we can do because they're not even.
Of course, yeah. You can incorporate it into here.
Our recourse is the uncertainty factor, which is standard, as you know, in the probability analysis.
Dr. Pucha, just sorry.
Did I answer your question?
Yeah. So I think in the Sun Belt state, early voting is favoring Republican compared to Rust Belt state.
Where is it, Prasanna? Which one?
The Sun Belt state,
Pennsylvania?
Georgia, Nevada, and Arizona. I think it's favoring Republican for the
early voting is favoring
Republican
Republicans?
In those Sun Belt state, but in the Rust Belt state, I think
the point you raised, Dr. Ghosh, and what my daughter said is a similar one.
Yeah, that's what I see the data for
You
last
also asked,
few days. Yeah,
right. You're right.
Compared to Rust Belt state, I think Rust Belt state, Pennsylvania, Wisconsin, Michigan, it is favoring Democrats. But
okay.
Rust Belt state,
compared to the
Sun
last
Belt state is
elections,
favoring.
are you talking about 2020, Dr. Ghosh?
Yeah, 2020, everything was favoring Democrats in the early voting. But this time it's a little different.
I hope I'm right.
I mean, so far, I don't know exactly
I know
until the day.
One thing,
but that doesn't mean, I mean, the on the voting day turnout could be totally different. So we do not know.
Yeah,
I'm
that's
just telling
possible. That's possible. No, but
observed
the thing is,
data.
tell me now, I'm going to ask you a question. Early voting, I didn't see the data. How many percentage of the people did you think, Dr. Ghosh is very informative?
I saw the
30%, 40%?
Yeah. So basically, like Georgia has done very good job in the early voting. They have like already 2.5 million votes already casted.
Oh, okay.
So, but either way, it's like a little bit different this time on those Sun Belt state. Republicans are putting somehow their effort is more on those Sun Belt state. So we do not know. I mean, again, we do not know towards the end what will happen, but just telling it's a little different than the previous cycle of election where 100% generally Democrats favor goes on the early voting.
Hey, something I do want to say for the rest of the people who are not asking questions, which is fine. The three people asked questions. One is first Dr. Ghosh. He's my colleague in civil engineering department. And then my daughter asked. Then Dr. Murthy asked. He and I did our degrees. He did his master's from PhD from Berkeley. We were around the same time we were doing our master's at IIT Kanpur. So I just wanted to identify these three people.
Dr.
Thadi participated in this. What, Nilu?
Dr. Putsa, Dr. Thadi also asked a question. He's asking, how big is your sample size?
How big is the sample size? We got about, I don't know, maybe all this. No, we got, okay, that's a good question. We got all the states, if you take how many states we have, we got the data from everywhere. So we have taken different polls. So you have to multiply 4, 5. I would say about a couple of hundred,
Okay.
more than that actually. But unfortunately, 30, it didn't come out. The 5 states, Hawaii, Idaho, Kansas, Kentucky, we didn't have any polls, number one. Number two, Arizona and Connecticut, we only have 1 poll. So to take care of all this, we use the uncertainty factor. Dr. Ramakrishna Thadi, he didn't come out, but that's one he has sent you, Kendra, the question. Kendra?
Yes.
Yeah, so I think I answered his question. So if you take all the states, most of them you had at least 2 or 3 polls. Suppose you have 50 states times. So I would say about a couple of hundred is the right data that we would think. Some of them we don't have, that's a different thing. Then I think we can do about it. And that only we could do is we fill based on have, and that we had to take care of. To adjust that, you have to use the uncertainty factor.
There's another
Somebody, his
question.
name is here.
There's another question. Do you cross-validate after the
Can you speak
result?
loud, Kendra? I didn't understand.
Do you cross-validate after the result declaration?
What happened to the sound? It's gone.
Can you
I
hear
can't
me
hear
okay?
you. Did I do something? Okay, speak loud, a little more. I'll come
Can you
closer.
hear me?
Sound is gone.
Are you able to hear me?
No, no. Very, very. It was fine till now. When the
Can
people
you-
ask questions, I could hear.
Can you hear?
Yeah, I can hear in my daughter.
Okay.
Okay. Ninad Kulkarni is asking, do you cross-validate after the result declaration?
That's what Kendra is asking?
No. Well, Kendra was reading that question, but it seems like you're having trouble hearing her. So
Yeah,
I'm
but
asking,
can you repeat the question, Nilu?
yeah, do you cross-validate after the result declaration? That's not my question. I'm repeating.
I know, it doesn't matter. No, I didn't understand the question. Repeat the question again.
Do you cross-validate after the result declaration?
No, we don't do it per se in our model. We don't cross-validate. No, we don't do that. We just, no. Formal cross-validation, we didn't do it. Who is the guy who asked the question?
Ninad Kulkarni?
Yes.
Oh, okay.
Hello, sir.
Okay.
Hello.
Fine. The answer is no. Formal cross-validation, no. But validation is done in the sense that we have, let us say, 4 polls, Nilu. So we're getting the results and all those things are lumped. So when we get different results, let us say popularity somewhere, somebody gives 40, the other one gives 80. So that whole thing, validation has to be taken care of in a different way through probabilistic analysis when you do the mean value and standard deviation things all the time. Yeah, I can hear you. Why we couldn't hear Kendra? I don't know. Something happened with her phone. Thank you for translating it, Nil.
Oh, yeah. Ninad could not.
Oh, incidentally, this is my daughter. She herself is an adjunct faculty. She has a PhD from USC in psychology. So, okay.
Okay.
Is everyone else not able to hear me?
I can hear you.
Okay, thank
I
you.
can hear you.
Thank
Yeah.
you.
Now I can hear you.
Okay,
Kendra?
great.
Yeah,
Thank
but
you.
that time, for about a fraction of a second, when my daughter translated it, I couldn't hear what you were talking about. It's good, at least we answered the question. Kulkarni or somebody answered the question, right? That's what, Nilu?
Yeah.
Kulkarni, yeah.
No problem.
Thank you. But at least we answered the question.
Yeah.
But I did say something else I have to say. The media here has been extremely cooperative. Deborah is not here now, Kendra. And last time it was Deborah. All of you were very supportive and cooperative. She had an interview she did for about, I don't know, 1 hour or something, right? Something like that. 45 minutes. So you're going to publish that also when you do the article, Kendra? All right?
Yes.
Okay. Thank you. Thank you.
Does anyone else have a question?
Kendra?
Yeah, I'm not seeing other questions, so I believe
No, but
we've
let me see,
answered
there
the
is
group's
something here in
questions.
chat. Can I look at it?
Which chart? Oh, yes,
Chart.
you go ahead and read the chat. Go
And,
ahead.
and see, and then see if I need to answer that. Is it okay?
Yeah, yeah, go
Let
for
me see
it.
what it is in chat. Ninad Kulkarni, we already answered. Okay, that question is over. Chat. Oh, there's only one which I answered that when my since I couldn't hear my daughter translate. Yeah, that's the only question I see, nothing else in chat. So if anybody else wants to ask, it's fine. Otherwise, I don't know. You're the host.
Yeah, no, thank you everyone for your questions, and thank you, Dr.
You have any
Pujaria, for
questions,
taking-
Kendra?
For myself,
Because this is not any discipline specific. Anybody can ask, you know.
do you have anything to add about margin of error?
It's about usual 1.5 to 2% or something like that.
Okay,
General, not anything unusually high, unusually low. Thank you. It's a good question. Margin of error is very important, especially when you deal with probabilistic values. Thank you, Kendra.
thank you.
I have one question, Dr. Putsa.
Yeah,
When you talk about uncertainty factors, gender, ethnicity, age, race, how do you determine these uncertainty factors? How do you assign
How
some
did-
value? And
No.
what is the mechanism to assign these the values to these factors?
so the way that we'll do is, Dr. Murthy, is that, for example, take the simple one, say gender. Okay. So we can see in the past how many people voted. We can have the classification based on age, and then we can look at the past. What is the final result? So we will see what kind of a role that gender played. Similarly, with age, we have the statistical data that we can always get. It's an open thing. How many men voted? How many women voted? And finally, what was the result? Whether Trump won or Hillary won. So based on that, we take the factor and then bring it based on the past history. That typically is done in an uncertainty factor. That's what we did for each one of them.
So similarly for each category,
For each
So-
state, and then we combine them,
you just combine and then you factor it. Yeah.
Right. I mean, it's still, even that itself is an uncertainty, the factor itself, as the name says. So there is another thing, I have to be careful with this guy. He's a PhD from Berkeley. Okay, so the question is that subjectivity is always there, Dr. Murthy. That's the trouble, right? Anyway, as you know, if you say send a paper for a review, so like that, even here, there is a lot of subjectivity. And so we're calling it a name which is typically used in reliability analysis and call it uncertainty factor for each one of them and then club them together.
So regarding the question somebody else raised, are you going to cross validate? So when you say, for example, are you thinking about readjusting? So do you go back and readjust these uncertainty factors, revalidate?
I mean, in the sense that the election is coming on 5th of November.
Yeah.
So public, we declared, yes, cross-validate that way, yes, because we still have three people, and we will come and see whether the factor is changing, whether we could adjust it. We intend to do that, but then that result, then it's over. I already told the people this is what I feel. And then we come out to say, and fourth morning, I think, no, it's wrong. I think Harris will win. Then that's going to stay only with our group. Already I came out. That's what. Yes, the answer is yes.
Okay. Thank you.
It's good now. You clarified the cross-validation. You're talking mainly for the factors. I didn't understand what he was. I got it.
Yeah, cross validation is basically you have to go back and readjust some of these
Yes.
factors, uncertainty factors.
Yes. We will do that. But then that will not be public because we're not going to have another meeture before the 5th of November.
Right. So that will be adjusted into built-in. That
Yes.
will be built into your model.
Exactly.
Model. For future. Yes.
Yes. The answer is yes.
Okay. Thank you.
You're welcome. There is another one. Hello, Kendra?
Yes.
I'm going to read this chat. Oh, the question is gone, but by the time I can read, I can read it. Hold on.
Okay,
Just wait. The question is, I'll read it for everybody.
thank you.
Kaustubh, I don't know who is Kaustubh, it doesn't matter. I have a question. How do foreign countries, specifically anti-American, affect the elections? I'll repeat. I have a question of how do foreign countries, specifically anti-American, affect the elections? That's a good question. I had to think that has nothing to do with my model. Public, what do people think? I mean, I can give my answer. Anti-American, they won't affect our election. I don't think so. How do foreign countries? Yeah,
maybe-
yeah. No, I take back. The answer is yes, because like I read that Russia interfered in the elections, and when Hillary, they wanted somebody. So, but they have their own ways. I don't know how they do, but the foreign countries, especially like Russia, we all right. They try to intervene into the American election. How they do, I don't know. I mean, I don't know how they do. Okay.